This video will help us understand the relationship that we need to use to solve for the variables here. Again, we are still on parallel lines and transversal, but now we are to solve for the value of x, y, and z that could satisfy the claim that line E and line F, the lines cut by the transversal line T, are parallel lines. So we do have this claim, and after this claim, we can actually use the special relationships on their measurements given by one postulate and four theorems. But for us to do that, we need to establish first which angles we are referring to first. Since we are solving for the value of x, we are going to use the angles having the variables x. I'm talking about this angle here and this angle here. Okay? So the first thing here is to first establish what angle pair is represented by these two angles here. Because if we are determine the type of angle pair formed by these two angles here, we can use the theorems and postulates as for the relationship and come up with an equation to solve for the value of x here. But then again, it's very important to always have this claim here. If we don't have this claim, everything will be in trouble. So let's look at these two angles here. So we have five pairs, corresponding angles, alternate interior, alternate exterior, same side interior, same side exterior. But both of these angles are found on the opposite sides. That would cancel out corresponding angles and the two pairs of angles using same side, because corresponding angles, same side interior angles, and same side exterior angles are pairs of angles formed by a transversal that are found on the same side of the transversal line. As you can see, the angles I am referring to here, the angles having the variable x, are found on opposite sides. So it's either they are forming um, either alternate interior or alternate exterior. And very obvious, they are not found on the interior, rather they are found on the exterior. So this pair of angles here are forming alternate exterior angles. Okay? So if they are forming alternate exterior angles, we can now decide which of those theorems and postulate we could use to for us to come up with an equation here. Take note that these relationships can only be possible with this claim. If this is not around, let's say if this is not around, we'll end up we'll just end up identifying which pair, what type of angle pair is formed. But since we do have that claim, we can actually use here the theorem for alternate exterior angles. We have here AEAT, or it stands for the alternate exterior angles theorem, which tells us that if a transversal line cuts two parallel lines, the alternate exterior angles formed by that transversal are congruent, or they have the same measurement. If we same measurement, we can now simply equate the values here to x minus 33 degrees is equal to x plus 31 degrees. How did we come up with this equation? We have come up with this equation following the claim that the alternate exterior angles when the transversal line cuts two parallel lines are congruent or have the same measurement. That is why it's very important for us to identify first the pairs of angles which are formed by these two angles having the same variable x. And out from this, we can just use properties of equality. And that would be addition property of equality, adding 33 both sides. So we have here 2x is equal to, that's just x, plus 31 plus 33 is 64 degrees. And then subtraction property of equality, removing x both sides, x will become 64 degrees. Before we could solve the other unknown for this given practice exercise, it's always important that you check it. Again, it's an important skill, not necessarily required, but it's an important skill. And in checking, we're going to use the equation form earlier. So you have 2 times that's 64 degrees. I already substituted the values. Minus 33 degrees must be equal, question mark now, because I have already substituted the value. And then that's 64 degrees plus 31 degrees. And that would become 2 times 64 is 128 degrees minus 33 degrees must be equal to 64 plus 31. That's actually 95 degrees. So this side will return to 95 degrees, and they have now the same measurement. That would mean this value here is correct. Okay. Now that it's correct, we can still further add a little bit of checking using the values here and making sure that they are equal. So the 2x minus 33 degrees, when substituted, that's 2 times 64 degrees minus 33 degrees. That's 128 degrees minus 33 degrees, which would actually result to 95 degrees. As for x plus 31 degrees, that's actually 64 degrees plus 31 degrees, which then return or yield to another 95 degrees. This checking further proves that the measurement of the angles with the binomial 2x minus 33 as given here and x plus 31 are equal as they are forming alternate exterior angles formed by a transversal. Okay? Now that we have established these concerns, then we can now proceed to number two, which is on the determination of the measurement of angle y or the variable y. Okay? This is supposed to be angle y, but since I am only using variables, so let me just use that one. But to do that, we need to look at the relationship of this angle y here to any angle having the variable x, yx, because x already is been solved already. Do not use the variable z here because you will just end up with an equation with two variables. I'm talking about this angle y here and this angle on the opposite side having the measurement 2x minus 33 degrees. Okay? This angle here and this angle here, we can always go back to the previous lesson. They are actually forming vertical angles. And by vertical angle theorem, the measurements of the vertical angles are the same or they are congruent. So if they are congruent, we could just always use an equation stating y is equal to the value of 2x minus 33 degrees. Okay? Vertical angles po sila. Okay? You could attack this by substituting the value of x here. You may always do that. Or you could always the additional checking that we did earlier in this form here. Since 2x minus 33, using the same variable and up to be 95 degrees, pwede natin i-substitute yan. Y is equal to 95 degrees. No need for a longer process or a longer computation solution because we already have solved it here earlier as a form of checking for number one, but as a form of help for item number two and probably for item number three. So that is the value for angle y or the variable y in the given equation. Okay, a given figure rather. So as for angle z, we will be using the relationship between the angle z and this angle here. They are adjacent angles. And if you can see, if we are going to look at their combination, they're forming this line here, line F. Or in short, they are forming straight angle. This pair of angles is actually under the linear pair postulate, because these two angles here are forming a linear pair. And the linear pair postulate tells us that if two angles are forming or angles forming a linear pair are considered to be supplementary. Supplementary means if we're going to add their measurements, they must yield 180 degrees. So with that statement, if we're going to add their measurements, that's 31 degrees, they must sum up to 180 degrees. Okay? And then we could solve the value for x here, or always use or always see here. We have already solved the value for this. That will become z plus 95 degrees must be, oh no, no question mark, 180 degrees. By subtraction property of equality, we can now say that the measurement of variable z is actually 180 minus 95, that's 85 degrees. So this is now the value for the variable z and variable y using the variable x here. Again, the variable x is solved from this equation using the claim here that the alternate exterior angles when two parallel lines are cut by transversal are congruent. Right? So this is still on congruence of angles because that is what the theorem is telling us. So for the next two videos, we are going to examine first the type of angle pair formed by um, angles which actually help us to have a solvable equation, and then look for special relationships in their measurements. So look for other examples similar to this and practice so you can improve your speed and your accuracy. Thank you very much. See you soon. Goodbye.